This is problem 19 on the fall 2015 exam. And the first thing to do before you do this problem, it's important to establish the positive direction. And I'm going to establish it as capital M moving to the right. But because of this pulley, the positive direction for lowercase m is moving to the left. So I would kind of denote positive as this way, counterclockwise, if you will. Now I'm going to draw my vectors, the two free body diagrams. So lowercase m is going to see the tension pulling it this way, and it's going to see a frictional force pulling it that way. It's going to see its weight pulling down, and then it's going to see the normal force applied by m against it. So I write that as n lowercase m capital M, which is to say the normal force on lowercase m by capital M. And that's going to be equal and opposite to mg. So if I write the two equations for this free body diagram, I have that t minus f sub s equals ma. And if I write the y one, it's that n m comma m minus mg equals 0. In other words, the normal force of capital M against lowercase m is going to be equal to mg. Now for friction, that is the one we care about because we need that normal force. That's the normal force at this interface. If we write down the free body diagram for the large mass, the free body for the diagram for the large mass is there's the applied force, which is going this way, and that's being opposed by the tension force, which is going this way, and the friction force, which is working against it. Now you'll notice that the friction force on capital M is in the opposite direction of the friction force on lowercase m, and that's because, again, these are a Newtonian pair. Lowercase m is acting on capital M and vice versa, they're equal and opposite. But the friction on capital M by lowercase m is opposing capital M's, the direction capital M would be moving. It also sees a tension going this way. In the y direction, we have the normal force being applied by the floor, and that has to be equal and opposite to the normal force of lowercase m against m, capital M, and it has to be equal to mg. But the fact is, we don't really care about the y component of this box because the floor has no friction, so we don't need to know the normal force. But we do need the x component, so we have that capital F, the force applied minus the friction minus the tension equals capital MA. So now we've got our two equations, and we're going to go solve this. And we're asked to solve for the situation or the limiting case or the breaking point for the static coefficient of friction. So this is a static problem, so the a's are going to be 0. So these two equations, when we rewrite them, we're going to substitute in for f mu s mg, and ma, of course, is going to be equal to 0. And so we get that t minus the friction is equal to 0, and here we've got that f minus t minus the friction is equal to 0. So now we have that just by bringing this over to the other side, we get that the tension is equal to mu s mg. And now if we substitute that into this equation, we get that f minus mu s mg minus mu s mg equals 0, and we get that f equals 2 mu s mg, and the answer is E. And that's the solution.